In dealing with Riemann sums in the definite integral, another important property to us is called the additive interval property. It says that if f is an integral on three closed intervals determined by a, b, and c, where we're taking a partition of a to c by finding some point b in between those two endpoints, then the definite integral on the interval from a to c of f of x dx will be the same as taking the definite integral of the interval from a to b of f of x dx and adding the interval from b to c. So we can add these two areas, which it would seem to make sense, to get the total area from a to c. Some of the rules for our definite integrals look exactly like the rules that we had for our antiderivatives, which we will deal with later. But in this case, our property says that if f and g are both integrable functions on the interval from a to b and k is some constant, then the function k times f and f plus g, by the way, f minus g, are also all integrable on the closed interval from a to b, and we can say in rule number one that if we take a constant, that the definite integral of a constant times a function dx on the interval from a to b, it will be the same as that constant times the definite integral from a to b of f of x dx. Similarly, if we take an integral from a to b of the sum or difference of f of x and g of x dx, it will be the same as the definite integral from a to b of f of x dx plus or minus, respectively, the integral from a to b of g of x dx. And now, as an example, we can just use this basic idea with a function like this one, where we're told that the definite integral from 1 to 3 of f of x dx is 3 halves, and the definite integral from 1 to 3 of g of x dx is equal to 1 half. We're asked to evaluate the definite integral of f of x minus g of x dx on the interval from 1 to 3, and by this rule we know that that means that we're taking the definite integral of f of x dx, and we're going to subtract from that the definite integral from 1 to 3. Again, these limits are important to us. The limits from 1 to 3 of g of x dx, and we've already been told what those values are. We're going to simply take 3 halves, subtract that 1 half, and so this value from 1 to 3 should be equal to 1. Now, we only complicate things a little bit by adding a multiplier, a constant like 3 or 2 into the mix, but if we use rules 1 and 2 together, we're really saying let's take 3 times the antiderivative times the definite integral, we're not going to do the antiderivative yet, of the interval from 1 to 3 of f of x dx, and add to that 2 times the definite integral from 1 to 3 of g of x dx. And once we get those values separated out, well, then we can work with them and say we're going to take 3 times our definite integral from 1 to 3 of f of x dx, which is 3 halves, and add to that 2 times our value of our definite integral on the interval from 1 to 3, which is 1 half. Working our numbers here, of course, we have 9 halves, and we're going to add 2 halves more. And so the sum is going to be our definite integral from 1 to 3 of the sum of 3f of x plus 2g of x, which is 11 halves.